Okay, so here we are kind of in the middle of the page. This will end up being a 3-video page. So we're here still in 2.2, the middle of the page. Page 1b is what you'd look for the notes here. And we're going to use the exact same goals and steps as we did from section 2.1. We are training ourselves all at once, and we're using this as a checklist. And a lot of the things in these first couple of problems, we won't use everything in the checklist, but it's there for when the problems get harder. But the goal stays the same. We're still trying to isolate x, get x all by itself on one side or the other, nothing happening to it, and then what we'll have is x equals that answer, that solution, what makes the equation true. And I put x in quotes here because it can be any variable, y, z, q, w, whatever flavor of the month you want. Here's our steps that we're going to be following every time. We're going to look to simplify both sides of the equal sign, or both sides of the equation, however you want to think of that. The first thing with simplifying, there's two things you want to do. This is one of the things I want you to get real clear about in Math 60. This will carry you very far. When they say simplify, what they're asking you to do is look to remove parentheses. Usually that means we're going to have to distribute. Sometimes it just means you multiply. Sometimes it just means notice that the parentheses are highlighting a negative value for you or something else that they're highlighting. After you've removed parentheses, then you look to combine like terms. A lot of the time, especially in the beginning examples, this will be already done for us. The next thing we do, these are the same steps as 2.1, is you're going to pick a side for the variable to be on, and it's you decide which side. Okay? It can be left or right. If you end up having variables, if you start with variables on both sides and you have to move the variable to one side, then they use the opposite operation of what you see of what's in front of the variable. So if you don't see anything in front of the variable term, then it's a positive, and you would subtract then to get it away from that side. If you see a minus in front of the variable term that you're trying to move, you would add it to both sides to get it to the side that you want. Then we're going to ask what's happening to x. And I usually use a little WH symbol on the notes as I go through the problem. And you'll answer that using what your knowledge is of order of operations. Again, x, whatever the variable is here. And you'll see me do it two ways in the notes. A lot of you will get to the point where you can do some of this stuff in your head. If you're making mistakes, though, if you're feeling like you're guessing or you aren't sure why you got it wrong when you compare it to the back of the book, you might want to go back and start showing your work here. And if you aren't sure what to show, mimic what you see in the notes, and then you'll get back on track. Once you're getting right answers consistently and you're feeling confident, you can condense the work that you show. Okay. Then we're going to undo what's happening to x. This is the actual solving process. The first two things where you're simplifying and picking a side, this is the process of rearranging to get the ax plus b equals c form, the kind of standard form of these equations that we're solving. And then the 3 and 4 are the actual solving process. So we ask what's happening to x using the order of operations to answer that. I've got it in list form, or you can do more of a visual kind of timeline. I'll show both ways as we go through these problems. And then to solve that, you've created a to-do list for yourself. And so the way you solve to get the answer is you undo what's happening to x. So you undo your list or your timeline. You go in reverse order, which means you'll go up the list or you'll go backwards through the timeline. And then you do the opposite operation of everything listed. And then finally you're going to check your answer. And the important thing about checking is you want to plug it into the original equation. If you've done any kind of rearranging, if you've done any kind of moving to one side or the other, simplifying, it's possible that you may have made a little error in that process, but then done the algebra solving process correctly. Your answer, if you plugged it into one of your rearranged equations, it would tell you that you had the right answer because you're checking it into what may have the mistake in it. So you want to go back all the way back to the original equation to plug it in, to confirm that you've made no mistakes anywhere along the line, either in rearranging it or in solving. So let's look at number 4 here, and then we'll go through 2 examples. You'll have a try, then we'll do a third video to hit the bottom of the page. Pardon me. Okay. First thing we do, just treat this as a checklist. We're looking to simplify, so we're checking to see if there's parentheses. Our goal, of course, is always the same, and that is to get x by itself. So we want to keep going until we see x equals some number answer. Okay? So we check to see if there's any parentheses involved that we need to remove, and there's not. That's already been done for us. Go down the checklist, and simplify includes combine like terms. And that's where you look on one side of the equal sign and see if there's anything that can be combined, or on the right side of the equal sign, anything that can be combined. And these 2 steps will most likely be done for you already as we begin 2.2. It's not really until we get to 2.3 where you're going to start to see some of this stuff, or really at the end of 2.2 you'll see some of it too, some like terms, things like that. But we always start with basic problems to get practice with getting the steps rehearsed. Okay, after we check for like terms, we make sure that the variable is on one side of the equation. We get to pick which side. I only see it once, it's on the left side. Again, that's been done for us in this particular example. Then we ask what's happening to x, and in this case, order of operations, if we were to plug a number in for x, the first thing we'd have to do is divide by -5. Again, the fraction bar means division. This is the same as saying x divided by -5. That's the same as what you see here. And so what's happening to x is the first thing, and the only thing that's happening this time, is we're dividing by a -5. And if you were to do it in a timeline version, timeline look to it, you could write that as just put the x first and then you put divided by -5, and you'd read that from left to right here as you put it in a timeline kind of visual look to it. Then we're going to undo that list. Now it's just what the book calls a one-step equation, or you'll hear that referred to. This is just there's only one thing happening to x. So the reverse thing here is not that difficult, but we still rehearse it so we're ready for when they do become more than one-step problems. We go up the list, or in terms of the timeline, we go from right to left on the timeline. So we go up the list, we change every operation to its opposite, so it's going to be multiplied by -5. As we go back through the timeline, again, we change every operation to its opposite, so it's going to be times a -5 here. And then that's what we do to both sides of the equation. I'm going to go ahead and rewrite this to give myself a little bit of workspace here. I'm going to multiply both sides by that -5. Notice how I put both sides completely in parentheses. That makes sure I don't leave anything out, because sometimes you may end up having to distribute to make this happen. So in this case, as I multiply here, there's no distribution involved in this particular case though. As I multiply, the point was to get rid of the -5. So don't try to do something extra fancy here. The -5s are just going to cancel each other. If you need to, think of it as -5 over 1 and then see the fraction multiplication. You'll see how it all, the 5s cancel top and bottom, the negative divided by negative becomes a positive, the x over 1 is just going to be x. And then -5 times a positive 8 is going to be a -40. Right? And then we want to check that answer. So we take our original equation, x over -5 equals 8. I'm going to plug that answer in here to where x was. Make a little note to myself, does this equal 8? -40 divided by -5 is a positive 8. This checks, it's a true statement. So I'm ready to write my answer in set notation. Sorry, I ran out of some room here. I needed one more line. And set notation is using these little braces. I call them French thingies. I don't know. They just seem extra fancy to me. But it's just a way of symbolizing, without having to say in words, hey, this is my collection of answers. This is my set. In this case, there's just one answer. We are headed in the direction in Math 65 where there's going to be more than one answer. And even as we finish Math 16, we talk about linear equations that have a line. There's potentially a infinite number of a set of solutions that make that equation true. So we want to start developing the skill of set notation. And this is just the beginning piece of it, is just putting your answer into these little braces here. Little fancy French squirrel, they're not really French, squirrely things. Okay, so that's number 4. That's just your basic beginning steps. I know it feels like overkill what I do here, but remember the point. The point is to get really good at this checklist, these steps, so if the problems get harder, there's no question what we have to do. We've been training for this all along, okay? It's if you are, you know, I don't know if you, but the Rocky movies, I remember watching that, and Rocky, when he was being trained by one of his trainers, had him do all these basic things, not even in the boxing ring itself. There are just all these extra things that seemed to have nothing to do with it. They seemed so basic, and yet he said, trust me, it'll make you ready for the fight once you get inside the ring. So kind of the same idea. It seems like overkill now, seems like this is not necessary. You can look at this and solve it. Great, I'm glad. But let's go ahead and practice these steps so they're ready when problems do get harder. Okay, let's look at number 12. Negative 54 equals negative 9 times z. We're just going to go through the entire steps again. Our goal is to get x by itself. Oh, I'm sorry, in this case it's a z. Careful not to make sure your z doesn't get looking like a 2 as you go through and get excited and start going fast through the problem. It's always an issue for me, so I watch for that. We are going to start by seeing if there's any parentheses that we need to take care of. We're going to simplify anything that needs to be simplified. There's not. This is done for us, so we're just going down the checklist here. Are there any like terms on either side of the equation? So cover up one side. Nope, can't go any further with negative 9z. Cover up the other side. Nope, negative 54, it's all by itself. All again. Cool, done for us. Pick a side. Z is already on the right side. There's no z's anywhere else, so we're okay with that too. Next, we ask ourselves, what is happening to z? If we were to plug a number in for z, what would you have to do first? The first thing you do is you'd multiply by a negative 9. And in this case, that's the only thing you'd have to do. It's what's known as a one-step equation. If we were to draw that in a visual kind of look, you would start with your z and then you do a multiply by negative 9, and we would read that left to right there to kind of describe what's happening to z in the equation. And then we're going to undo that list. So in terms of the we're going to undo what's happening to z. That's how you strip everything away and get z by itself. So we go up the list, if you did the verbal written out list here, and with one step, you don't have to change the step numbers, it'll still be the first step. But every operation changes to its opposite, so multiply becomes divide. As you go right to left across the across the timeline version, we come to the times negative 9 first, and you then tell yourself it's going to be divide by negative 9. The sign of the actual number does not change on that. And then let's go ahead and follow that prescription that we've made for ourselves. We're going to divide both sides by negative 9. And I'm using the fraction bar because it is the same, means the same as division. So on the right side, the 9's cancel. Negative divided by negative is a positive, or you could think of that as a negative 1 over negative 1. Those are going to each cancel. I'm left with z is equal to negative 54 divided by a negative 9 is going to give me a positive 6. And then I get to check that. And I go back to my original equation. This is really super critical when you are doing a bunch of rearranging or simplifying at the beginning of the problem. So I'm testing to see if my answer of 6 works in the original equation, and I do end up with negative 54 equals negative 54. That's a true statement, so I've checked my answer. I'm ready to write it in set notation, which is just a way of highlighting. It's the same as if you would circle your answer or put a box around it, but this is saying, hey, here is my answer. 6 is the one solution that makes that equation true, positive 6. Okay, so now time for you to tell, question, copy, talk it through to yourself if you have no one else to tell. Note any questions, make a little highlight, star, question mark off in the margin here so that when you come to class and it's time for group work, it's time for your question card, I come around and say, hey, are there any more questions? You can flip right through your notebook and go, yep, I'm still wondering about this. And then copy, make sure you get everything copied. Go ahead and try number 8. Hit pause, come back for the answer. Okay, number 8, you should get an answer of -8. And then I'll see you at the bottom of the page for the last example and try.